So let me introduce myself first. My name is Ankush Chowdhury. I am the founder of this Learnomate Technologies. We have multiple trainings available in our institute. We provide the offline training in Pune location, and we also provide the online training from where like anyone can join. So we have a training program starting from Oracle DBA, Hadoop Spark training. We provide the training on SQL, PL, SQL, then SQL Linux fundamental training. And the most important thing is Oracle DBA, RAG DBA, and Golden Gate technologies. So all these trainings we are providing under the platform called Learnomate Technologies. So we are getting connected here to understand about the Hadoop Spark technology here. Okay. So let's try to understand about what is Hadoop, what is Spark, why we are using this Hadoop Spark technology, and all those things we are going to learn in our today's lecture. So let's try to understand about the Hadoop first. Okay, what is Hadoop? Anyone know what is Hadoop in this class?
It is a technology of big data management system.
Okay. Let's try to make it a more interactive session so that um, we will also get some sort of confidence. We'll also get some sort of like if we are talking to each other, then it will be more interactive and we will have a lot of fun here. Okay, so everyone is learning here, so let's try to make like that only.
Right.
Okay.
So as per my understanding, Hadoop is just like the framework, I would say, which is majorly deal with a huge amount of data.
Correct, absolutely.
This is which I know only.
Yeah. What about others? Anyone want to add something?
From use data to gather some scientific or means more related data.
Correct.
For that we use Hadoop.
Correct. So basically what happened, like see, nowadays all the business are working on the data system only. Data system means those people who are having a huge amount of data, they are the richest person in the world. Because see, earlier did what happened, like we were not able to utilize that existing data, but nowadays there are multiple framework comes which will help you to analyze your existing data, and from that data you can take a decision that what will be benefit to increase your business itself. So let's say whenever you have a huge amount of data is there, okay, so Hadoop is a framework which is mainly helpful to process your huge amount of data. Let's say I have one data warehouse is there where I have my huge amount of data is there, and that data I am going to process it. See, there is a process called processing. Okay, we got the data. I will take that data as input to my Hadoop framework for the processing purpose. I will process it, and then I will store that data into some format. I will store that data somewhere, right? So Hadoop is mainly responsible to process your huge amount of data, Now, why only Hadoop? Why not the other system? Now, if I take the example of Oracle, okay, Oracle also can be used to process your data, but Oracle can process your data in the form of rows and columns, basically your tables. Let's say we have a data which is structural kind of data. Structural. When I talk about the data can be of different type. One, we called it as a structural kind of data, structural. Another type of data we called it as a semi-structural data. Another type of data can be your non-structural data. Non-structural means a data which cannot be in the structure. Now structural data means a data which can be stored in the form of rows and column. Like let's say we have a data in the form of table. That is a structural kind of data. So when you have a structural kind of data, that data can be processed by using a RDBMS system like Oracle is there, MySQL is there, PostgreSQL is there. Then we have SQL Server is there. Okay, we can do all those things with the structural kind of data. When it comes to the semi-structural data, means let's take an example of your JSON, your XML file. JSON, maybe you have heard about the JSON, XML. All those type of data can be processed by Oracle also nowadays with the latest version, but previously it was not possible also. So when it comes to the non-structural data, let's say you have a data in the form of logs. You know, whenever any application is running, that will generate some log information. Now that is not a structural also, and it is not a semi-structural also. So that type of data you cannot store into the MySQL or Oracle or all those things. That is not possible. It cannot take the input itself. So your RDBMS database cannot be helpful for you to process your non-structural data. Another problem is like when it comes to the RDBMS database, every system, whatever processing framework what we have seen, all those framework is having horizontal scaling. Okay, now what happened, let's take an example. I'll tell you one example. Let's say I have a huge amount of data is there. So initially you consider that this data is of size 1 terabyte. So I'm considering that there was a system which was taking that data and it was processing it. So those system, let's say there is a one machine who is processing this data. There is one single machine who is processing this data. Now when this machine, when I say a machine means basically consider a server which is taking that data. Now whenever you are considering any particular node or machine, when I use the terminology called node, machine, okay, you consider that it is a server only. So whenever you are having a huge amount of data, that data is going into a machine, and that machine to process something, we need huge amount of CPU, we need huge amount of RAM, that is, and we need storage also to store your data. Now the problem is like the processing framework what we were having before the Hadoop. Let's say you allocate some 100 GB, let's say you allocate some 100 GB of RAM. So initially you were able to process the data. Now as soon as this data reached to 2 terabyte and then it reached to 3 terabyte, what you have done, you increase your RAM also 200 GB, 300 GB. But later on you realize that even though you are increasing your RAM, even though means same server, you are just increasing your RAM. So you are trying to make that server very powerful to process your data, but still after certain time you realize that even though you are increasing horizontally means the same server, you are trying to increase the number of RAM, the number of resources, still it is not processing your data. Because there is a single person, you consider a very layman example that there was a single person, he was able to, lift 100 kilogram of weight initially. Now he is little stronger, so he will increase to 150. But at the end it is a single person who is lifting the weight. Now the problem is like every person is having some limit, right? Every person is having some limit. More than that he cannot lift it. So what will happen, instead of using one person, can we have a multiple person? Can we have a multiple person who will lift that weight? Let's say instead of one person, I added one more person here. Instead of one person, I added one more person. Or I can add one more person again, 3 persons are there. Now easily they can lift it, right? So what I mean to say, when you have a huge amount of data, and if that data is keep on increasing, a single processing unit, a single server cannot process that huge amount of data. For that you need to add multiple servers, and these multiple servers will be connected internally to each other and behave like a single machine. That is called cluster. And we are talking about the Hadoop cluster. What is Hadoop cluster? What is Hadoop cluster? Hadoop cluster means it is a combination of multiple node. Let's say we have a node 1, we have a node 2, we can have multiple nodes. But all these nodes are internally connected to each other. Let's say I have node number 3 also. Even though they are a 3 different machine, but behave like a single machine, and that is called cluster. Why it is a cluster? Because there are 3 machines are there, but they are behaving like a single machine. That is called cluster. But what is Hadoop cluster? Because we are going to install Hadoop software on machine number 1, Hadoop software on machine number 2, Hadoop software on machine number 3. That is the reason we are calling it as a Hadoop cluster. Now cluster is a terminology which is very common with respect to any technology. Like nowadays I'm working with the Oracle, so there we called it as a Oracle cluster. There we called it as a Oracle cluster. Why it is a cluster of Oracle? Because instead of Hadoop we are installing Oracle here. Instead of Hadoop we are installing Oracle here, and that is called cluster. So whenever you are working as a Hadoop Spark developer or Hadoop developer, you will get a cluster. You will get a cluster where multiple node will be there, multiple machine will be there, and on that machine they are going to install that Hadoop software, and that is the reason we called it as a Hadoop cluster. Now coming to the processing part. Now when you have a huge amount of data, whenever you have huge amount of data, we got to know that Hadoop is a framework which will process that data, see what is mean by processing means I have a huge amount of data, but that data is very chunky wunky here and there. That is not a sorted data. If I see that data, it is a unwanted data is also available. Let's say I have my database size, my data size is 3 terabyte, but when I see that 3 terabyte is not important for me, I need 1 terabyte of data, because 1 terabyte of data is my meaningful data, and by looking to that data only I can take my decision. So Hadoop is a framework which will process that data, process that huge amount of data, and finally it will store that data in the form of output. Somewhere it will store. I will tell you what are the different sources where you can store that, and finally I'll get 1 terabyte data. So basically I have a huge amount of data. We called it as a big data. Huge means big. A data which is very huge in the size, we called it as a big data. Now big data cannot be measured into a 1 terabyte or 2 terabyte. Any data which cannot be processed by my normal system, that is a big data for me. Let's say I am using 32 GB RAM in my laptop. So if my laptop is able to process this data, then it is a good data, means I can process it. But any data which cannot be processed by my 32 GB of RAM, that is a big data for me. And what is the solution for that big data? Hadoop. Hadoop provide you a solution. Hadoop provide you a solution to process this huge amount of data. And after the process, you will get meaningful data that you are going to use for your business purpose. Till now, able to understand?
Yes.
Everyone?
Yeah, I have one questions on that. The Hadoop cluster, right? So the cluster, as we know it, the bunch of server,
Yes.
which is gonna combine together. So these Hadoop clusters, can we say, or it's based on a master-slave architectural?
Correct.
It's
I'll
it's
show. Yeah, in next 10 minutes, I'll discuss about master slave.
okay. So means the Hadoop is completely based on master-slave architecture, right? Not
Correct.
the without this.
No. We have multiple. We have master node will be there, and we have slave node will be there. I'll come to that part in next 10 minutes. Okay.
Okay. So
So we got
Hi,
yes. Somebody saying something.
Yeah, so you said like Hadoop is used only for processing the data, or we can get the output, right?
Yes.
Yeah, so for getting the output, we are in AI ML also we can train the data and for getting the output. So which is faster we can use? Can you please tell us one real life example on both the cases, Hadoop and the AI ML?
Can you please be louder what you said? Little
Yeah,
less.
so Hadoop, you said that it is used for processing the data and getting the output, right?
Correct.
Yeah, so we have different models in AI ML as well, right?
Correct.
To train the data and we are getting the output. So can you please tell us the real life example in which Hadoop can be used and it is faster as compared to AI ML where we are training the data and we can get results faster while using the Hadoop?
No. See. Okay, I'll come to that part. I'll show you. Okay. So what happened now? Let's come to that part. Like we have any type of data. Okay. So why Hadoop is very important nowadays? Okay, why Hadoop is very important nowadays? And nowadays means nowadays Hadoop is not that important. There is a one more technology comes into the picture. We called it as Spark. I'll show you what is the difference between them. So this Hadoop is basically providing two things. One is providing you. It is providing you a processing framework. Okay. So Hadoop is mainly responsible to process your data. That is what I told you. Like you have a huge amount of data, you process it, and it also provides you one more feature. We called it as a storage solution. It is a storage also. Hadoop itself is having their own storage also. That is called HDFS, Hadoop file system. Now in our Windows, we are using an NTFS file system, right? So when you are installing your Hadoop software on your machine, you'll also get one storage, and that storage we called it as a HDFS. HDFS is basically a storage provided by the Hadoop. And there is always one discussion is happening in the market that does Spark replace the Hadoop? Does Spark replace the Hadoop? So we are going to learn about one more technology. We called it as a Spark. So what is Spark basically? There was one problem with the Hadoop. For Hadoop internally was using one mechanism, we called it as a map reduce, to process your huge amount of data. Okay. Now let's say I have a data which is available here. It is an input for me. And to process this data, we were using Hadoop, and Hadoop internally was using a MapReduce framework, a MapReduce engine it was using to process that data. Now, basically, if you ask me the architecture, how Hadoop project works, you consider like that. Let's say you have a huge amount of data. Let's say initially my data size is 10 terabyte. So basically you use filter number one. Just take an example that you use filter number one. And finally, after the filter, you got some 7 terabyte of data. Then again, you use some group by function and all. And again, finally, you got some, just take an example that 5 terabyte of data. Again, you use some filter condition. And finally, you got output of, assume that 2 terabyte. That is my final output. Now, problem what happened here with this MapReduce framework, what Hadoop is using, the intermediate data what you are using right now, the intermediate data means the intermediate output. Like initially input was 10 terabyte, and after the filter one you got 7 terabyte. Again you perform, so this is called intermediate output. Intermediate means in the middle. So what happened here, whenever you were using intermediate output means you done the first processing and you want to start the second processing, but that output will be the input for your second operation. This is the output, but this will behave like an input for my this particular operation. This group by function, this will be the input of my first output. So what happened here, this intermediate operation was done on the storage level. In the storage there are two things are there. This intermediate, what they were doing, when they were doing the intermediate operation, they need to be done, that needs to be write somewhere into the storage, and that we are writing on HDFS level. So basically, you know one thing, that this HDFS you can consider like, just take an example that it is behave like your normal file system, like your NTFS, C drive, D drive, the way, just for the understanding, you take the example like that. And you know one thing, that anything which can be written to the storage level, the input, the read operation and write operation is very costly there. The read and write is very costly whenever you are storing your data to the disk level. So basically problem was, when I have a huge amount of data, and that huge amount of data, when after the filter or after some transformation you are storing it to intermediate result, that writing, and then again you are reading it for the next operation, it is very costly operation. So then they thought like, okay, can we do one thing? Anyway, this intermediate operation is not something which I want as an output. What is my output? My output is here in the last stage. Can we process this into the memory? Can we process all this intermediate operation into the memory? So then they thought like, okay, let's discuss about the Spark. The problem with the MapReduce framework was, all the intermediate operation was done on the disk level. Now when it comes to the Spark, all your intermediate operation will be done on memory level, where it will be done on memory level. And anything which is available in the memory, is very faster, because let's say you are sitting into the exam, okay, and you saw the interview question. If you know the answer which is available in your memory, you can write down the answer very fastly, right? Because your processing will be very faster. But when you don't know the answer, what you will do? You will open a book, you will read it, and then you will write it. So it will be very slower. So what happened? Hadoop was providing two solutions. One was processing and another was storage. So this processing was done by the MapReduce. Now what they have done, this Hadoop processing part they replace with the Spark. So basically, when you get an input, that will be processed by the Spark. Now if I draw the diagram, let's say this is my huge amount of data, this is my input. Now it will be processed by the Spark. Because Spark is doing all the intermediate operation in the memory only. It is not writing. And when the final output comes, let's say you are in the final stage, if you are asking Spark that, okay, now I want to write it, then it will write it in the final stage. But intermediate operation, let's say filter 1, filter 2, filter 3, and after the filter 3, if you want to write it, then only it will write it. But where it will write it? Problem is, Spark is a processing unit. It does not have any storage. There is no storage for the Spark. Spark is not coming with his own storage. So which storage it will use? It will use the storage of your Hadoop only. What is that? We called it as a HDFS, Hadoop file system, which I told you 2 minutes back. So basically, you got the input, you process it by using a Spark, and when it comes to the output part, it will use a storage of HDFS, which is a Hadoop file system. It is a storage of your Hadoop only. So basically, in the final word, what I want to say, Hadoop is not replaced by Spark. Hadoop framework, Hadoop processing, which is your MapReduce, is replaced by the Spark, because Hadoop does not have a storage. Spark does not have his own storage. Spark is using HDFS storage only to store your data. Don't consider that only HDFS is the input or HDFS is the solution. There are multiple other things are there. Like, I'll tell you one example. So when you talk about the Hadoop or Spark, okay, Hadoop or Spark, the good thing about the Hadoop and Spark is it can process a data from any type of data. Just like I told you, like it can take a data. Let's say this is my Hadoop or Spark. Let's say this is my processing engine. If you take the example of Hadoop or Spark, okay, if I take the example of Hadoop and Spark, it can take a data from your, as the input, it can take a data from your RDBMS database. Let's say you have a data available in your RDBMS database like Oracle or MySQL or any other database, PostgreSQL. You can process their data also. Let's say you have a data available in NoSQL database like Cassandra, your MongoDB, whatever NoSQL databases are there like HBase. It can take an input from this NoSQL database also. It can take a data from your local file system also. Local file system is like, let's say I have a data available in my C drive, D drive. It can take a data. Let's say in Linux operating system, we are going to create one mount point called /data. I have my data available here. So local file system also, it can pick up a data. It can pick up a data from the HDFS also, Hadoop file system. It can pick up a data from the Hadoop file system. It can pick up a data from the storage like cloud. In the cloud, we have Amazon S3 or any other storage. So basically it can take a data from any platform. That's not a problem. And it will be processed by your Hadoop framework like MapReduce and Spark. It can be processed by here. And when it comes to the output, and now I process my data, finally I need to store my data, right, somewhere. So I can store my data to the HDFS, which is my Hadoop file system. I can store my data to the 𝐓𝐤, which is a data warehouse tool of Hadoop. I'll talk about that. You can store your data to the NoSQL database also like HBase, Cassandra. You can store your data to the local file system if you want. You can store your data to the Amazon S3, which is a cloud platform, or anywhere. You can store your data anywhere. So basically you don't need to use multiple softwares for the input purpose. You don't need to use multiple software to process the data. You don't need to use multiple softwares to, it is a complete set. Everything is available with this Spark and Hadoop, everything. So we have a multiple options are there. Come up with the any type of data, structural data, semi-structural data, unstructured data. Everything will be processed here. And finally you can store the data anywhere. Clear, guys?
Yes. Hello, Ankush sir.
Yes.
Kumar this side.
Yes.
Yeah, I have questions. What will happen with unused data? Will we keep this data for a certain period or it immediately delete?
It's all depend upon the business to business. Okay.
Yeah,
Some,
generally I see they keep data for 7 days, I think.
that is called retention period basically. Okay. Those data
Yeah.
which you think that is of no use, or but there is a chances that it may used. So for certain time they will keep their data and after that they will delete it. Okay. That's called retention period.
Yeah, thank you.
Understanding na till now everyone?
Yeah, one question might be it's okay, so here the HDFS we can make it as a source, right? And Destiny also we make it as HDFS.
Correct.
So both the scenes where we can say the nested concept, right? So with the nested stuff we can maintain on a same cluster, right?
What is nested? I don't know.
Means the HDFS like our source, right?
Huh?
So HDFS is nothing but somewhere it's gonna output of the Hadoop output, right?
Correct.
So whatever the first SDFS is gonna generate it. So can we say the same Hadoop the output as an SDFS?
No, basically what happened in HDFS, we are going to create a directory structure. Okay.
Mhm.
What we are going to do, let's say my input data is available. Okay. Just take example. The HDFS will behave like a simple Linux command. That is the reason I'm always saying that if you want to understand about the Hadoop or Spark, there are three prerequisites are there. One is SQL, one is Linux, and third one is any programming language, any. Okay. Now this Linux, why I'm asking, because this Linux is all about the HDFS only. Here we are going to learn about the Linux command, basically HDFS, completely Linux command. Okay. Now when you say about the Hadoop HDFS file system, let's say my input is available here. Just take example that there is a directory I created /data/input. Okay. Then I process it by using the framework over here. Okay. By using framework, I process it. And finally, I want to store my data. So I'll store my data into the /data/output, this location. Okay. In this location, I'll store my data. So this location and this location is completely different. Okay. Now on the top of this location, you can create your, there is a concept called Hive. Okay. And Hive is basically when people want to do some SQL level of queries. Like let's say you want to run select star from table name. So that data is basically coming from here only. Okay. So this concept I'll talk about maybe in tomorrow's lecture. Okay. There I'll show you what is this Hive and how
Okay.
it works internally.
Okay. Means just for the like the first SDFS we are prepare it, right, which is also generated from the Hadoop Spark, right? First SDFS.
Okay. See, HDFS is a file system. Okay.
Okay, so the same file systems means maybe the source and destiny, whatever process we needed, so we can maintain on a same Hadoop cluster. So there is no need to
Correct.
be maintain the first SDFS generated
No,
from the
not like
Spark
that.
one.
Not like that. No.
Okay, that's which my question is.
What I'm saying, when I draw this diagram now, okay,
Mhm.
if I want to draw the same architecture, I have a node 1, node 2, and node 3. There will be shared location will be there, and that shared location we call it as HDFS. Okay. So if you load a data from here by any chance, okay, you can access the same data from node 3 also. When you install a Hadoop software, basically what I said, a cluster is all about the, even though there are three different machine, but they are behaving like a single machine. Why they are behaving like a single machine? Because their HDFS is common. Okay.
Yeah.
I'll come to that part. Okay. I got to know, but your understanding is like it will be like input will be some different HDFS, output will be some different HDFS, not like that. Okay. It is the same HDFS.
Okay, so if the SDFS is different, so in that case we can use the two SDFS from a different we can process on the same cluster. So that also possible, right? It's logically
That is possible, correct?
Yeah. Okay.
But it will be very costly, you know.
Okay.
Very costly. Okay. Now, again, when it comes to the Hadoop now, okay, there are two type of processing is dead. Processing we are doing generally when you want to process huge amount of data. So there are two type of processing we do. One processing we called it as a batch processing. Okay. Another type of processing we called it as a streaming processing. क्या बोलते उसको? Streaming processing. Stream processing. Okay. Now, what is batch processing? What is stream processing? Batch processing means, let's say you got your data today. Okay, let's say I got some set of text file, I got it today. Just take an example that these are my some CSV files are there or text files are there, which is having some huge amount of data. Okay. And I got that data on 4th of December. 4th of December, 5 p.m. I got one file. So what I will do, the processing of this file, I will do it on 5th of December. 5th of December means next day I'll start processing. I got the file today, I will process that file on 5th of December, means next day I will process it, and finally I will store my data somewhere in the output. But when you got the data 5 p.m, when I process it, next day 5th December I will get new file again on 5 p.m. Usually the architecture will look like this only. Next day same time I will get a file, and this file I will process it on 6th of December, same time I will start the processing, and again I will store my data in the form of output. So if you try to understand this type of architecture, this is called batch processing. This is called batch processing. Batch processing means you got a file today, you are going to process it by tomorrow, and then you will get a data or the output, required output, you will get it. So this is good for some sort of business, and most of the projects, if you ask me, all business are working on batch processing only. At least wherever I work, I saw that the people are working on batch processing. But there will be certain scenarios where I need to understand about the streaming processing. Streaming means, in streaming what will happen, let's take example, same example. Let's take example, I got some data, there is one single file is there. Just take example that this is the same file, and there is a timestamp is mentioned there. Let's say it is 4th of December. There is an application log which is writing down something. Okay, writing down something, and as soon as I get one record, into that file, or let me show you one more example. Let's say there is one table is there. Okay, let's say this is my table. The table name is EMP. As soon as I get one record into that EMP table, immediately I will start processing immediately. Okay, I will not wait. As soon as I get the one record, immediately processing will start, and immediately it will show the output. Again new record came. Let's say you got the record on 5 o'clock to me 5:20, 5:22, again you got another record. In 2 minutes you got another record. 3 minutes, again you got multiple records. Within a second also you are getting so many records are there. But this processing framework in a such way that you design this programming in a such way that as soon as you get a data, process it and show the output. Just take an example of in layman word, in real-time example. If I want to take traffic, I want to know how much traffic is there in the Pune location, Pune Wakad location. I want to know. In Pune Wakad location, I want to know the traffic current scenario. So when I'm showing you current, when I'm sending you some data, okay, there are 20 vehicles are there, 30 vehicles are there right now. When user is sending the input, are you going to show the traffic details by tomorrow? No, I want real-time data. I want real-time. That is called streaming processing. Streaming processing means as soon as the input come, process it and show me the output. Now this output, you can show it in the form of that graphs and all, right? You can see, okay, here everything is red. You can use the Google map, right? So Google map is showing that Google map is showing that, okay, there is a traffic. Now they are not showing me the yesterday's data, they are showing me real-time data. If you take the example of cricket, right, you can see the continuously the graph and all those things you can see over there. That is a streaming kind of things. Whenever the flight, the departure and arrival will start, that flight attendant people, they will see the temperature details also. Like, okay, how is the temperature? Like, okay, whether the cloudy environment is there, can they do that landing or not? They will come to know in the real time only. They cannot wait for next day, right? That is called streaming kind of data. So streaming kind of data means as soon as you get a data, process it. So you don't need to start it manually. Okay, don't consider that you need to check, okay, whether you got the data or not, whether you got the input or not. You don't need to do that. Everything will be done automatically. You will get a data, automatically you will process it, and finally you will see the data in the form of chat and all. That is called streaming kind of data. So when it comes to the batch processing, let's say whenever you want to use batch processing, that is done by the Hadoop framework. means your MapReduce. MapReduce support basically your batch processing. It does not support streaming processing. Streaming is not done by the Hadoop. But who can do both the things? Spark. Spark is a uniform technology which can do batch processing, string processing. Everything can be done by using this Spark framework. Very, that is the reason I'm telling you, like, Spark is a in-memory computational framework. In memory, it will do everything. It can process any type of data, structural, semi-structural, JSON. It can take a data from any location, local file system, Hadoop file system, RDBMS, cloud platform, Hive databases. You take any example. It can store a data in the form of any format, no problem at all. So this is how it works, and it can process batch processing as well as streaming processing. Everything can be done by using Spark. Understood?
Yeah.
So from where to start? Okay. Now what I will do, first of all, we'll start with the practice and all. Okay. So basically, you install one software called Download VirtualBox. Okay, Download VirtualBox for Windows. Go here, click on the first link, and click on the Windows host and install this software. I'll cancel it because this software is already installed in my case. You just double click on it, say next, and install it. So your Oracle VirtualBox will looks like this. Oracle VM VirtualBox will looks like this. By using this software, uh, I have one ready-made machine is there with me. Ready-made machine means I will give you one ready-made machine, and if you install that ready-made machine, okay, if you import that ready-made machine on this virtual box, the Hadoop related things are already installed in that. Like your HDFS is already installed, your Spark is already installed, Hive is already installed. All these things are already installed in that. Okay. So the environment will be ready for you to understand the technology. Okay, so that way we can do the things practically. For laptop configuration, minimum 8 GB of RAM is required for practice purpose. Minimum 8 GB RAM is required for practice purpose. Okay, that is very important. If you have more than that, that is also really good. Okay. Related to the Spark, we can do the practice on Windows also, because Spark is as I said earlier, Spark is an individual entity. Spark does not require Hadoop, right? Spark does not require Hadoop. Only for storage purpose, it may require HDFS, but as I said, you can store your data on the local file system also. Spark is very powerful. So Spark, I will tell you how to install on Windows also. Even Spark is available under that machine also. So I'll give you a ready-made machine. You just start installing that. Okay. And we'll go one by one like that. Clear, guys? Why we are using VirtualBox? By using this VirtualBox, you can use multiple machines. Like, see, you can see here that I have Ubuntu machine is also running here. So we are using Ubuntu only to install your Hadoop. So I have already installed that, because when you are working as a Hadoop Spark developer, you don't need to install all this software. That will be done by the admin team. They will do that. You just need to use that. So I will talk about the profile now. Okay, profile, what we are doing and what we are calling it as in the market. So some people are calling it as a data engineer. Okay, so when it comes to the data engineer, we are the same people. Some people are calling it as a PySpark developer also. PySpark developer. Some people are calling it as a Hadoop developer. Okay, and some people only call it as a Spark developer. So data engineer is a very big stream actually. Okay, data engineer. So basically when it comes to the data engineer, data engineer, Spark developer, anywhere actually. So basically what happened, this data engineer technology is provided by the multiple organization. Like there is something we called it as a Apache. So whatever Spark we are using, whatever Hadoop technology we are using, everything is provided by the Apache. Apache is open source. Open source means anyone can use it. Anyone can use it. Anyone can change the code of your this framework also. Anything which comes under the Apache, that is open source. Open source means you don't need to take any additional license for this. If you take the example of Oracle database, if you take the example of any other database, okay, like SQL Server, even Windows 7 operating system, Windows 10, these are not open source. If you are using Windows 11 machine, you need to take the license to use that Windows 11 machine, and then only you can use that. Why Hadoop and Spark is very powerful nowadays? Because it is free of cost. You don't need to pay any charges for that, because it is free of cost. Free of cost means for licensing cost you don't have, you have only cost of setup. Only setup is cost is there, otherwise it is open source. So this Spark is provided by the Apache also. Even the cloud people are also, there are multiple vendors, they are also providing their same technology. Like if you take the example of GCP, if you take the example of Azure, if you take the example of AWS, they are also providing the same to same things. Okay, but when it comes to the Spark is everywhere. Okay, Spark is here also. What happened, this Spark is developed by the people. There was a person who developed the Spark, and he handed over that Spark to the Apache. He handed over that, and then he created one company called Databricks. He created his own company called Databricks, and Spark is open source here. So what he did, he made some changes. This is a community edition. Community means anyone can use it. He created his own edition. We called it as a commercial edition. Commercial means now if you want to use the Databricks Sparks, okay, they have their own cluster also. You don't need to set up any cluster. They will only provide you. So let's say you want to run any Spark job or you want to run any Hadoop job, they will only give you their own resources, own cluster, everything they will provide you. And he has come up with the company called Databricks. So some projects they are using Databricks also. Some projects they are using Spark with AWS, Spark with Azure related things. Like in AWS, when I say, so they will not use HDFS actually for storage purpose, because there is a one more file system AWS is providing like HDFS. We called it as a, what is that? Amazon S3. They are providing that. And even Azure also have their own storage. GCP also have their own storage. Okay, but at the end the concept is same only. Clear guys, everyone?
Yes.
So that is the reason people are calling it as a GCP data engineer, Azure data engineer, right? AWS data engineer, because they are expecting that you should have some knowledge about the services provided by their respective cloud platform. But at the end, everyone is using Apache only. Everyone is using Spark only. Spark or Spark related technologies. Okay, because it's a very big competition in between for all the vendors actually. Now you cannot understand GCP specific, AWS specific, or Azure specific. Okay, why I said that PySpark developer, I'll talk about that one also. Because the thing is, when it comes to the Spark can be written with multiple languages. Like Spark you can written with, Spark is a framework which is again processing your huge amount of data with respect to your batch processing or irrespective of your streaming processing, and it will store a data. So Spark needs one language for supporting purpose. What is that language? It can be your Java, it can be your Scala, it can be your Python also, R, it can be your R language. R is mainly useful for that machine learning people are there na, they're going to use it. We are going to focus on PySpark. Python with Spark, we called it as a PySpark. Python with Spark, we called it as a PySpark. So when it comes to the Java also you can use, Scala also you can use. You use anything, but their role is little small. You know, Java, Scala, or Python, or any. Our role. I'm not saying that you should have very advanced level of knowledge of Python. No, basic knowledge, that is more than enough to understand the Spark, because we will mainly play with the Spark only. But if you have advanced knowledge, that is absolutely well and good. Okay, so Java like mostly used by the banking system, but again, like writing down PySpark application with the Java is very complex. So in the market there is a demand to the Python only, because Python is scripting language, small code, can be written very fastly, and development will be very faster. Those people who are coming from the Java background, they know that what is the pain to create that jar file and then run that, and it's very difficult. I already worked with the Citibank on this Java Spark. It's very difficult. Difficult means the execution process is very time consuming. So we replaced Java with the Python and we started working on Python, which is called PySpark. So huge demand is there in the market for the PySpark developer. So we'll discuss that. So first we'll start with the Hadoop. Okay, we have already gone through the introduction of Hadoop and Spark actually today. First we start with the Hadoop. We'll discuss about HDFS, Hive, all this concept first, and then we'll touch to the PySpark, Python and Spark. Okay, any question, guys?
Yes. So where we use the Cloudera, like I listen this software.
Which software?
Cloudera.
Cloudera.
Yes.
Cloudera and Hortonworks was two different company initially. Okay, Cloudera was a separate company, Hortonworks was a separate company. Now Cloudera and Hortons, what they have done initially, like I'm telling the old story. That time what they have done, Hadoop is a combination of multiple components are there. Like when I say a Hadoop, tomorrow I'll discuss about that Hadoop components. It is a combination of multiple components. So what they have done, this Hadoop and Hortonworks, they created their own machine. Let's say they installed one server called CentOS server. Okay, and they install all that component inbuilt only. The way I'm giving you ready-made machine na, same way they also created their ready-made cluster. Means all that software will be already they install it in that machine. And by any chance, if you got any trouble to this machine, like basically, you know, Apache is an open source, so they are not going to charge and they are not going to give you support also, correct? So then that company comes like Hortonworks and Cloudera. What they have done, they have created their own, like Horton was created by Ambari. There is one framework was there, Ambari. Then they created that machine. And it's the same machine. They also have their own Hadoop. All the Hadoop related components was installed in that. Initially, there were the two different companies. So if I'm using Cloudera setup, let's say I went to the Cloudera, I said, boss, I need one Hadoop cluster where all these things should be already installed, and I need your support also. So Cloudera people was providing a support to us also. By any chance your cluster is having some problem, let's say my cluster is getting stopped automatically all the times, there is some problem, so they were able to support you that time by paying the charges. Again, Apache was not giving you support, correct? Because that day it's a open source means when it is open source, you are not paying anything to them, they will not provide you support. But when it comes to the company level things, like, you know, commercial things, we need a support. Even if you are using Oracle, you need Oracle support. If you are using MySQL, you need MySQL support. If you are using any of software, you need support from their respective vendor. So this Cloudera and Hortonwave provide you the support. For that you need to take their licenses, like additional amount you need to pay. The client is supposed to pay for that. Now initially what nowadays what happened, both the company has been merged. So if you go to the Hortonworks, if you go here, download Hortonworks. If you go here, this is a Cloudera machine, but Hortonworks Sandbox product is also mentioned here because both the company has been merged nowadays. So they are also providing you this HDP sandbox, this the ready-made machine which I'm giving you now, same machine they are also providing you. So it is asking where you want to install that. I want to install this virtual box. Fill up the details, and it will give you one machine. That machine also I'm having right now, and let me check whether I have deleted that or not. Here you can see this is a Hortonworks machine, but this machine need 10 GB of memory to run itself. 10 GB I have allocated here. If you have 8 GB of RAM overall in your system, 10 GB, do you think that you can give? No, that's not a problem. That's not possible. So it is a very heavy machine actually. So that is the reason I created one very simple machine. Simple means work is doing same thing, okay, absolutely 100% same to same work, but I created only the machine for which the services I'm using right now, because it created a lot of services. It will use Zookeeper, Hive, Hadoop, then in the background lot of services will start, and it required a lot of resources of your machine, your local machine. So those people who are having very good amount of memory, they can use this Hortonworks machine. Those people who are not having that good memory, they can use this Hadoop machine. Okay, so this machine is same. Only the thing is I have installed the required software only. I did not install any additional software which are of no use for us, so that I can allocate some 4 or 5 GB of memory, and this machine will run very smoothly. Even your laptop will not get hang. Understood?
Yes, thank you.
So Ankush sir, like I have one doubt. After like learning this course, whether we would get administrator role or developer role?
Developer role.
Okay. So for developer, like compulsory, we need to learn Python or something.
If you have some basic knowledge, now again I'm saying like basic knowledge is important. Okay. Even though if you go to the YouTube channel, multiple channels are there, they are discussing about the Python and all. Okay, even we will also take in our class. So if you have some basic knowledge about the Python, then it will be easy for you to understand the, good thing about the Spark is even you can write down your plain SQL queries also. Let's say select star from table name, that command, that query itself you can put it into the Spark job.
Okay.
Only query itself. So SQL is important, and if you have some Python basic, that is also
Okay. So like as such, like right now I'm working as a core Oracle DBA. And from like the main challenge for me is like night shift in Oracle core DBA.
I know that. That
So
is the
that's
reason
why yes,
that is
like
the reason.
so from now, like as my limited knowledge, like cloud, rack, and this Hadoop Spark things, like I'm getting these three options.
See,
And
personally, even I was a Oracle DB. Okay.
Mhm.
If you ask me why I switched the career, even I was getting very good salary in Oracle DB.
Mhm.
But only one reason which forced me to switch my career from Oracle DB to Hadoop was because of the shifts only. Because when it comes to the shifts, a lot of you'll end up with the problems like health issue and all.
Yes,
Okay,
very special this will comes.
that is a problem. Otherwise, Oracle DB is very very good. Even whatever trainings we are providing, we started, and after that I left the job itself. So that's how. Like you can think about that. Okay,
Okay.
that will make your life easy. In Hadoop, when you see, if I compare Hadoop with the Oracle DB, Hadoop is having lot of calls, lot of Spark basically, lot of calls are there, lot of Like daily you will get so many calls, like you will get fed up with the interview call itself. So it's very booming in the market nowadays. If you know Spark, then your life will be really good. And again, in terms of package 9, you ask whatever you want, they are ready to give you.
Okay. And so cloud things also come in Spark, or cloud is different thing?
Now again, same thing. Do you want to use Oracle with the cloud, or you don't want to use it? It's up to you. Okay,
Okay.
it's not compulsory. So those like nowadays, like if you have some cloud specific thing knowledge, then that is good only. So we'll try to cover some cloud concept, whatever I know, okay, in this class.
Okay. Thank you.
Understood, guys? Today's lecture. Remember?
Yes.
Yes.
Yes, sir. Okay, let's connect. What we'll do, we'll connect tomorrow. Okay, tomorrow is so continuously we'll connect. Okay, I'll update in the group, our group. Okay, I
Same
think
timing, sir?
in this class everyone is from our that paid batch only, right? Not from other batches. No?
Yes.
Right.
Yes.
Okay, Amit is
Yes.
not there, and some people are not, but most of the people are from my paid batches only. Okay, so those people who are interested for this training, they can reach out to me on this number, or you can also drop email to this email ID. Okay, we already started, guys. We are not doing any time pass. I'm really sorry. We'll start today and we'll continue from tomorrow. Okay. Okay, guys, then thanks. Bye bye. I'll share the recording also. You'll get the recordings with 3 months of access. I'll fill up the forms and everything. Yes, you were saying something, anyone? No?
Oh, thank you.
No.
Okay,
Thank you.
thanks. Bye.